A confidence interval is a type of interval estimate computed by statistics in any data that might contain the true value of an unknown statistical parameter.
It shows how confident we can be at that sample drawn from the confidence intervals that came from the population within given standard deviation. They can also be used to indicate the reliability of an estimate.
In other words, if samples are taken from a population with a 95% confidence level, then we could be 95% confident that these samples would contain the true mean for the whole population.
To compute the confidence interval of a sample, you need to know the mean and or the standard deviation of that sample, and you will need to calculate the margin of error.
Today, we'll be seeing how to calculate a confidence interval for a mean when the sigma is already known. The steps for calculating a confidence interval are very similar, regardless the type of confidence interval that you are looking for. Now, here's a process to make our work easier when finding the confidence intervals. Step number 1. Check conditions. Begin by making sure that the conditions for your confidence intervals have been met. Step number 2. Estimate the sample mean. This involves forming a simple random sample from the population. Step number 3. Critical value. Obtain the critical value C that corresponds with the confidence level. These values are found by consulting a table of C scores. Step number 4. Margin of error. Calculate the margin of error where n is the size of the simple random sample that you formed before. And 5. Conclude. Finish by putting together the estimate and the margin of error.
To get to the critical C, we must first make a chart. This chart is divided into 4 different levels. Get the confidence level, which is 1 minus alpha. In this case, it will be the decimal form of the percentage. Then the significance level, which is only alpha. Then get the alpha and divide it by 2. To get the critical C, we will need to use alpha divided by 2, the answer that it gave us, and we need to find it in the heart of the chart. To read the chart, and on the left side and on the top side, you will combine these two numbers and it will be your critical C. In many of these cases, the number can be between two different numbers. In this case, you will find the average and that will be your critical C.
The formula for the margin of error is critical C times sigma divided by the square root of n. The equation to get the confidence interval is x bar minus e is less than mu and less than x bar plus e.
30 communities in New York, population of 10,000 each, gave an average of 140 reported cases of robbery per year. Assume that the standard deviation is known to be 45 cases per year. Find the 90% confidence interval for the population mean annual robbery cases. N equals 30, which is the 30 communities. The X bar is the 140. And 45 is for the 45 cases per year, and the confidence level is of 90%. The C is what we saw in the chart, which is 1.645, and the formula is the margin of error, which is C times the standard deviation over n to the square root, which is 13.515, and the x should be subtracted by the e, which is what we just saw, 13.515, and then the x should be added to the e. So we're gonna have 140 minus 13.515 less than the mu greater than 140 13.515, which is 126.48 less than the mu greater than 153.515.
Problem B is telling us to find a 95% confidence interval for the population mean annual robbery cases. First, we're going to classify our terms just like we did with the other problem. First, we're going to get the n, which is 30. X bar is equal to 140. The sigma is equal to 45. And now, our confidence level is a level of 95%. So now we're going to get the critical C. Once you do the procedure to get the critical C of the 95% confidence level, you shall get the number 1.96. Now we have all of the terms, and once we got them, we are going to find the margin of error, and we're going to plug in all of our terms, which is going to be 1.96 times 45 divided by the square root of 30, and that will equal to 16.103. Now that we have our margin of error, we're going to return to the original formula in that way to get our final answer. What we're going to do is x bar minus margin of error, mu is greater than that answer, and then we're going to do x plus the margin of error, and that answer will be greater than the other one. We're going to do 140 minus 16.103, and that will give us 123.897. And in the other section, to say that, we're going to do 140 plus 16.103, and that'll give us 156.103, and that'll be our final answer. On problem C, we are going to find a 99 confidence interval for the population mean annual robbery cases. Just like the other two problems, we are going to find first our set of terms. N is equal to 30, x bar is equal to 140, sigma is equal to 45, and of course the only thing that changes is our confidence level, which is 99%. What you're going to do is to get the critical C of that 99% confidence level, and once you do the procedure, it's going to give you 2.575. Okay, once we got all of the terms, first we're going to get the margin of error. So we're going to plug all of our terms, which it will be 2.575 times 45 over the square root of 30, and that will give us the number 21.156. Now that we have the margin of error, we're going to return to the original formula, and just like we did on the other two problems, we are going to sum up the x bar plus the margin of error and subtract it. So what we're going to do is 140 minus 21.156, and that'll give us 118.844, and for the other problem it'll be 140 plus 21.156, and that'll give us 161.156.